Hello and welcome to another video. In this video we're going to be doing maximum odd binary number. And in the problem you're given a binary string S that contains at least 1, 1, and you have to rearrange the bits in such a way that the resulting binary number is the maximum odd binary number that can be created. Return a string representing the maximum odd binary number that can be created from the given combination. Note that the result string can have leading zeros. Essentially you're given a bunch of ones and zeros, and you are asked to make the best odd number you can, the biggest. So in this first example, you only have 1, 1. So first of all, you have to know that for an odd number, its least significant bit, meaning the rightmost bit, has to be 1. So this bit has to be 1. And then the rest, now you only have 0, so this is the only one you can make that's odd. In the second example, they kind of show you a hint. So once again, the last number has to be 1, but then this is the biggest number you can make, because you have one more 1 to move wherever you want, right? And wherever you put the 1 represents the power of 2 that we have, right? So like this last bit is 2 to the 0, this bit is 2 to the 1, 2 to 2, 2 to 3. So wherever you put the 1, it's gonna be 2 to the some power. So you obviously want to just put it in like the biggest spot you can. So you get this, and then this will give you 9. Yeah, because 2 to 3 is 8 plus 1. If you put it in other spots, let's say you do this, this would give you 3. This would give you 5. So this is the best. And so that's kind of the hint they're hinting at. It's a pretty easy problem. Essentially, once you're given a bunch of ones and zeros, like let's say we're given just like 5 ones, or here, say we have 5 ones and we have like 4 zeros or something. So essentially we know that like, okay, to make an odd number, well, let's make this an array just to make it easier to see. So here we go. And let's just get rid of this. So we have 9 numbers total, right? There we go. And let's pretend this is our number, right? So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to 6, 2 to 7, 2 to the 8. So we can just ignore these indices. So essentially, you know you have to put a 1 here. Like this has to be here. But then if you just know basic bit manipulation and how bits work, wherever you put ones is going to give you the 2 powers, right? So the biggest number you can make, like let's say we can only put 1, 1 here and then the rest has to be zeros. The biggest number you can make is just putting it at the leftmost, right? Because it'll give you 2 to the 8 plus 1. If I put it somewhere else, it'll be smaller, right? It's very similar to decimal. Like imagine you can make a decimal numbers where you can put ones and zeros, right? So let's say you can have like this kind of thing. Well, what's the biggest number? Like let's pretend this number was in decimal. The biggest number you can make with 2 ones is just a 1 here and then all zeros here, right? This would give you like some 10 to the 8th thing, or yeah. So it's the same kind of thing with powers of 2. If you have 1, 1, you want to put it in the leftmost spot possible. If you have 2, you want to put it in the leftmost 2 spots. If you have 3, 4, 5. So the biggest number you can make is just this, right? You put the ones in the biggest like values they can have, which is the leftmost values. Put in zeros in the rest of it. I think I actually, oh right. So we only have 5. We only have 5 ones, so we have to have 1 here. Like we have to have this to make it odd. So we can't put all 5 over here. But the rest of it, just put the ones and add the leftmost position possible. Put the zeros right after, and just have a 1 at the very end. And that's basically no matter what your number is, that's always going to be your solution. And so this is pretty straightforward. You can just use like a counter. So you just go through your string, count up the ones, count up the zeros, and then you just build a string. So the first part of your string will be all ones, and however the number of ones is going to be the count of ones minus 1, because you have to leave 1 for the end. So it'll just be like 1, 1, 1, 1. We have 5 here, so we can build 4. Then the next part of the string will be all your zeros. So 0, 0, 0, 0. And then finally, you'll have a 1 at the very end. And that's always going to be the best. So it's like a greedy solution. Like I said, kind of the same thing with decimal. Like imagine if these weren't ones and zeros, if this was a decimal value, right? If you have 5 ones and all zeros for a decimal number, what's the biggest one you could build? It would still be this kind of thing, right? If these were powers of 10 instead of powers of 2. Same exact thing. So basically that's all we need. So we can code that. So essentially we're going to count up the number of ones and zeros. We can just use a counter, or you can just go through your string and count it up. So we're going to say count equals counter of s. And what this does is it'll give you a dictionary of however many ones and zeros we have. So if we actually print count here and just return an empty string for now, just to show you. So let's take a look. Here it is. So we have two zeros and one in this number. And in this, we have 2 and 2. So it's pretty useful. You can just use a dictionary. It doesn't really matter. And this is basically going to be of one space regardless, because we only have 2 values that we're counting out, right? So we only have 2 key value pairs. So then we need to return our string. So our result is going to be, so the first part is going to be the number of ones. So we can just say like 1. And in Python, you can take a character and multiply it by something to give you a string. So we can say 1 times the number of ones. So this is going to be counts of 1 minus 1, right? Because we need to save a 1 for the very end. So this is the first part of the string. Then we can add the next part of the string, which is just going to be very similar, except it's going to be all your zeros. So 0 times counts of 0. And finally, at the very end, you just have a 1 at the very end to make it odd. And we don't even need this result. We can just return straight away. And so this is basic string concatenation, right? So like this part, if you're doing this in another language, this part is just a bunch of ones up until the count of your number of ones, right? So if you have 5 ones, this will be 4 ones. Then we have all of our zeros, and then we have a 1 at the very end. And that's going to be the greedy best solution we can get. So there we go. As far as efficiency, I wouldn't worry too much. Like for these negligible runtime solutions, it doesn't really matter. Once the runtimes are really big, then you can really see like which code is better. But for these small runtimes, it's like tiny things. Like, did you make a variable or did you not? So it doesn't really matter. And yeah, length of string is only 100. The biggest thing is what you want to avoid for strings is you definitely don't want to have something like a string. So this would be like the worst solution, right? So imagine your solution was like, okay, let's just loop through all of the counters. Let's just have like a result variable, and let's loop through all of our, so we can say like for, or like while counts 1 does not, or is like, let's say greater than 0 or something, or let's say greater than 1. We can say like this. This would be like very bad. So if we did this, and then we did this, counts 1, subtract. So essentially we're saying, oh, let's just take the counts of 1 and let's keep adding a 1 to our string every time. And we can do the same thing for the zeros, right? So we can say like this exact same thing. So we can say like, while count 0 is greater than 0, let's add a 0 and let's subtract. And then finally you can like do return result plus 1 or something, right? For the last one. So this would be really bad. And like, even though the runtime is like this, because you're basically just adding a new character to your result every single time. So if this got really big, like every time you do a string concatenation, you're basically making a new string, because strings are immutable in most languages. So this is like the only bad solution. So just make sure that when you make your strings, you either like join up characters or make them like efficiently. And you're not, imagine if your string is like 1,000,000 characters and you're adding a character every time, you'd have to like recreate the string every time. So that wouldn't be great. But yeah, anything other than this kind of solution, at least I believe in Python. I mean, I know for sure in Python they're immutable. There might be some like under the hood thing to optimize it, but yeah. And let's just go back to our old submission here. So copy that, put that in. Okay, so let's talk about the time and space and all that. So like we obviously have to go through our string to get the count of every character. So that's O of n. And then like this is O of 1 space, because we, like I said, you only have two key value pairs, and your string could be 1,000,000,000 characters. You're only counting zeros and ones. And then this doesn't count as like space, because this is output. Like we have to return this. So this will be O of 1 space. We do have to go through the number of ones, right? But the number of ones is going to be proportional to the length of the string. So the number of ones plus the number of zeros will be the length of the string. So this is O of n and O of 1 space. And yeah, I think that's going to be all for this one. Pretty easy one. So if you like this one, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.